Another part of the load chart documentation is the range diagram. The range diagram is very important for net capacity calculations and gross load calculations. Let's go ahead and talk a little bit about the range diagram for the next few minutes. The range diagram contains information for the operating radius, found at the lower part of the range diagram document or image, boom and extension lengths from 35 feet of boom up through the 56-foot extension over on the right hand side of the diagram. Boom angles, we've got the boom angles highlighted in red from 0 degrees up to 70 degrees, and the lines, the diagonal lines are the indicators for the different boom angles. The range diagram also contains information for the tip to ground distance, or as they say, as it's labeled on the diagram, height from ground in feet, which is again the tip to ground distance or the tip height. And this tip height is used to calculate the wire rope deductions, and the wire rope deductions are used or a component of net capacity calculations or gross load calculations. That's pretty important. A common mistake made on load chart problems is a miscalculation of the wire rope weight, and that miscalculation of the wire rope weight may be because the range diagram was not interpreted properly and the tip to ground height was incorrect. Let's go ahead and take a closer look. Here's an example. I'll just show you how I use the range diagram. What is the tip to ground distance with 90 feet of main boom and a 50-foot radius? Find the arc for 90 feet of main boom. Here we've got 90 feet of main boom, and there's an arc that corresponds to 90 feet of main boom. Find the vertical line corresponding to a 50-foot radius. We have all of our radius values along this lower axis. There's 50 feet. So let's go ahead and create a line there to illustrate what we're doing. Okay, so we've got the 90-foot boom arc, the 50-foot radius vertical line. Those two line segments intersect. At that point where they intersect, draw an imaginary straight line over to the left. And on the illustration here, it's not imaginary. I'm actually putting in a green line to illustrate that imaginary straight line over to the left. And wherever that straight line ends up, that is your tip to ground distance or your tip height, 80 feet. The tip to ground distance with 90 feet of main boom and a 50-foot radius is 80 feet. And 80 feet is a distance that you'll use for your wire rope calculations. A note, and I'll mention this again, it will be illustrated in the next example, but let's go ahead and mention it now because it's important. If the intersection of boom and radius fall between two tip heights, use the greatest tip height. What does that mean? Well, if your green line ended up falling between 80 feet and 90 feet, you would use 90 feet as your tip height. If it fell between 70 feet and 80 feet, you would use 80 feet as your tip height. Always use the greatest tip height. Another tip, and I think this is a helpful tip. This is what I've done when I've taken the exams. You will be given some scrap paper to work your problems out on. You can use the edge of that scrap paper as a straight edge. Just line up the edge of the paper along with the vertical line for a 50-foot radius. Go ahead and find your 90-foot arc, follow that down to where it intersects with the vertical line for 50-foot radius. You've got your straight edge here. Now once you've done this, all you need to do is rotate that piece of paper This intersection point is going to be your axis for the paper's rotation. Go ahead and go ahead and rotate it. Then you'll have follow that edge of paper all the way over to the left, and there it is, 80 feet for your tip to ground distance. They really frown on writing on the load charts during the exam. So this is one way you can do this and not have to write on the load chart. Another example, and this one will show some of the gray area that you might encounter when you're using a range diagram. What is the tip to ground distance with 110 feet of main boom and a 65-degree boom angle? Just like before, find the arc for 110 feet of main boom. 110 feet of main boom, there's the arc to follow. But we're not dealing with radius this time. We're dealing with boom angle. And we have diagonal lines representing boom angle. So find the angled line for 60 degrees boom angle. We are already asking, why not 65? 65 is not a number on the diagram. Can't use 65. Use a real number. And just like when you're finding capacities, you always want to go down to the next lowest boom angle. So 65 degrees is not on the chart. We go down to the next lowest boom angle, which is 60. And we use that to find the intersection of the 2 points. So we have a 110 degree arc, a 60 degree angled line. Now we have an imaginary line going from that intersection over to the left. And it falls between 100 and 110 feet. Like I said before, if you run into this situation, if it's between two tip heights, always use the highest or the largest distance. Between 100 and 110 feet, use 110 feet. Again, let me read this note again. If the intersection of boom and radius fall between two tip heights, use the greatest tip height. Also, let's go ahead and let me read this note down at the bottom. If radius or boom length are between values, use the next longest. If boom angle, which we have in this problem, if boom angle is between values, use the next smallest. You can also use the straight edge or your scrap paper as a straight edge for this type of situation as well. Just line up the edge of your paper along with the diagonal line for 60 degrees, rotate it around, and the line to the left or the edge of your paper, you follow that edge over to the left. This edge here, follow that over to the left. It ends up just below 110 or between 100 and 110, and we're going to use 110 as our tip to ground distance or tip height. Now that's a quick refresher review of using a range diagram for the Grove telescopic boom crane. You probably will only need it on those problems where you have extra wire rope and you have to calculate a wire rope deduction, but go ahead and practice using the range diagram as you do the practice problems, or as you view the other videos that illustrate different problems. You'll see the range diagram being used. Again, practice is what you need to get to the point where you'll do well on the exam.